Hello. This tutorial is an introduction to programming using CTC's QuickBuilder programming environment. We're starting out, as you can see, with a clean slate. The first thing we're going to do is define the controller and the rack and modules that are in the controller. So we'll go over to the Resources window, and by right-clicking on Controllers, we'll be able to select the CPU we're using first, and that will appear in our list here. And then we'll right-click on the CPU, and we can add a rack. And in this case, let's say we're using a 4-slot rack. Once the rack is defined, we can populate it using I/O modules. So by right-clicking on that, the new choice will bring up categories of I/O modules. And let's just say we're using one combination digital input and output module. So I'll click on that. Now, you'll notice that there's a plus sign here by the I/O module that we just added. I can click on that plus sign, and that will show us all of the I/O points represented by that module. Now, what I'm going to do is go down to Digital Output 1. What you're seeing here are the default names for these I/O points. I'm going to right-click on this, click on Rename, and I'm going to give this a little more user-friendly or explicable name. So I will call this O1_blink. What we're going to do is write a very simple program here that's just going to blink an output on and off. So this name sort of fits the bill. Now, notice the convention I'm using here of starting the name with O1_. That tells us this is output number 1. It's just a way that will help us later on quickly find the physical output represented by this if we have to do any troubleshooting. So we've named that, and now we'll do one more thing before we go on to writing our program, and that is to define a variable. We'll define it in the controller, and we'll set up a register that I'll call R10_counter. And this is one that we'll just use as an iteration counter. We'll add one to it each time we go through our program loop. Now, before we go on, you'll notice that there's a properties sheet down below the resources window. And using that, we can define various aspects of the resources that we've programmed in up here. And you'll notice we're still on R10 here because that was the last thing we programmed. We can put in an override for that basically assigns it to a specific register number. And I'm going to assign it to register 10. And you'll remember I used R10 as the first part of the name. And again, this is just a troubleshooting help. If we want to group registers together, we can, so that registers that share similar functions can appear in sequential order when we're monitoring them. Now, one other thing we might want to do is go back up to our controller and change some of the properties for the CPU. For example, we could give it a name. And in this case, I'll just call it my controller. We can choose an optimization profile, and you'll notice it says optimized debug here. Now, what this means is that the program, once we've finished it, will be compiled into C code, in other words, optimized for performance prior to being downloaded into the controller. And debug means that the symbol table will also be downloaded along with the program. Both of these are typically pretty good ideas. Now, down below here, we'll put in the IP address. Now, CTC controllers are shipped standard with the IP address 192.168.1.53. And of course, you can change this at any point. But since we're starting with the controller right out of the box, we'll put in the default IP address. And the only other thing to check up on is down here where it says Make Startup Project. We want to make sure that says true. You can have multiple projects downloaded into a controller. Only one of them will start up when the controller first starts running, and we want this to be the one. So we'll say true, make this the startup project. So now we can write our program. We'll begin our program by creating a start task. You'll see this icon that is a bold letter T, and the tooltip says Task Start. And if I click on that, you'll see a Start Task block will appear. I can drag that in our project window, just up into the corner here. And here we can, if we want, give our start task a name. So I'll right-click on the name block and click on Edit Step Task Name. We'll call it My Program. We'll be really creative here. And now we could, at this point, if we wanted to, program in some local variables. We could create, for example, some constants if we wanted to that might represent analog set points or motor positions or whatever that will be used later in the program. Having them all in one place here, again, makes it a little easier to maintain the program. In this program, we won't really need any of those, so we won't do that right now. Now, with the start task highlighted, with it selected, I'm now going to add the first step to our program by clicking on the step icon here. This just has an S inside of it. And you'll see a step appears. Now, notice this blank box that appears between the start task block and the step we just created. This usually would, it's a provision where you can put in a transition event, a transition condition that is some precondition that must exist before the program will proceed from start task into this new step. Now, we don't really recommend that you use this. The reason for this provision is for compatibility with the IEC 1131 programming language standard sequential function chart. And we actually have a much more powerful way of creating transitions from step to step by putting instructions within the steps themselves. So in this case and throughout this program, we'll just say these blocks we'll leave empty. Now, again, this first step, we can rename it, give it a more descriptive name, if you will. So I'll call this Blink On, because that's what we're going to do in this step. Now, it's time to start writing some of the instructions that are going to go into this step. There are a few ways you can do this using QuickBuilder. If you're just starting out, I'm going to show you the recommended way until you get familiar with the syntax of our programming language. And that is to use the step editor by going up in the View menu and selecting Step Editor. And you'll see that just appeared down here. The step editor is a syntax-directed editor. It takes you through the process of building a new instruction, and by giving you finite choices, it physically will not let you make a syntax error. So when you're first starting out, this can be helpful. As you become familiar with the language, you may find it faster just to type freehand instructions and then look for syntax errors later on. There's also a means by which you can drag and drop from the resource window into the code pane to automatically put in an instruction relating to, say, an input or an output. So we'll start out now. This is the code window here where it says QS4 code. And we're on our first line to begin with. And you'll see in the step editor, there's an icon that the tooltip says insert statement below. If I click on that, we have our choice of classes of instructions. Now, what we want first is an assign instruction because we're going to assign a value to an output. We're going to turn the blink output on. So by clicking on assign, it shows the different types of assign instructions. We want a set instruction. And here's the framework for the instruction. Because we only defined one output, there's only one choice here for the set instruction. And that's our blink output. And under state, if I click on that, open it up, it gives us two ways of defining the on-off status of this output, either true or false or on or off. They mean the same thing. They do the same thing. It's just whatever makes more sense in the context in which you're using this output. So we'll say on, and I'll insert that. And you'll see it appears over in our code window, set O1 blink on. And it ends with a semicolon, as all QuickBuilder instructions do. So that's inserted automatically by the syntax-directed editor. Now, I'd like to show you how to enter a comment. We'll open up a new line here. And as is typical in programming languages, we can start a single line comment with 2 forward slashes. And there we have it. Now that we've set the output on, I want to increment our counter register. So we'll create a new instruction over in the step editor. And that will also be an assign instruction. And the type is increment. And the variable we want to increment is R10 counter. And we want to increment it by a value of 1. And we'll insert that. And there's the instruction, R10 counter plus equals 1. Now, you can also put comments in, multi-line comments, using the convention of a forward slash followed by an asterisk. And ending with an asterisk and another forward slash. Now we just need one more instruction to finish out this step. We're going to put in a delay instruction, so we'll delay, let's say 300 milliseconds before we go on to the following step. So I'll insert a new instruction, and this will be a flow instruction of type delay. And the time in milliseconds again is 300 milliseconds, and I'll insert that. And that's it. We're done with this step, and we can go on and program the next step of the program. So with this step highlighted, I'll click on the step icon again, and it will add another step immediately below. Keep in mind, we're leaving this transition condition blank. We'll just be flowing through from the first step to this next step. We'll rename it. And we'll call this, blink off. And here we'll start with an output instruction to turn the output off. So we'll assign set output 1 off. We'll insert that. And we'll have another delay instruction now. We'll say still 300 milliseconds, another 300 millisecond delay. We'll insert that. And now we'll want to return back to the blink on step again, and we'll just loop this program continuously. And the way to do that is we can click on the bubble at the bottom of our last step here, and drag from there up to the previous step. So now when we fall to the end of the step blink off, we'll go immediately back up to blink on and repeat the program again. So we are now finished with this program. We can save it. So we'll say save project as, and we'll give it a name. And now we can translate it, which converts it into C code. It basically compiles the program, and you'll see it did so with no errors. And now we can publish and run the program, downloading it to the controller. This just takes a second, and you can see it says success. So it downloaded successfully. And I can tell you the controller that's attached to my computer here does indeed have output number 1 flashing on and off. So that's all there is to it. Very simple process. And of course, obviously there are a lot more instructions that can be used. You can do multitasking to have multiple sequences running simultaneously. But this shows you the very basics of getting started with QuickBuilder. I hope it was useful to you. Thanks for watching.